All right, so here is your review assignment for Unit 3. Such an important assignment to be able to go through to make sure you didn't forget anything. So I want you to notice the page before, if you look at it, it gives you a summary. So our first lesson was on position, velocity, acceleration, then different rules. Using your calculator, ignore this part. We have a much newer calculator to be able to do that. Implicit differentiation, and then we did related rates, which are story problems. And then the steps we did. So this page is really important to be able to summarize the unit that we did. And at the bottom you can see some geometry formulas that we might have to use. All right, so let's start reviewing. So the best is to do it first, press pause, or press pause, do it first, and then press play. That's the best. That's how you learn. But obviously, on video, I can't make you press pause and try it first, but I hope you do. If you do need my support, you need my support, and we're going to do it together. So first of all, a bunch of derivative questions. So can you take the derivative here? In fact, I might not even write down the question right away, but just do the derivative. So power rule, 4x cubed, 3 times 3, 9x squared, x, 1, and the derivative of negative 2, 0. Number 2, where it's already calculus friendly. In fact, I'll write down the function so I can see it easier. So x to the 1/3, subtract x to the negative 1/3. Can you take the derivative using the power rule? So 1/3 times 1 in front, subtract 1 to the exponent. And negative times a negative is positive. When I subtract negative 1, subtract 3, that's negative 4/3, and that's it. Number 3, we just did number 2. Number 3. Now for this one, I'm going to write it differently to make it super easy, so I don't use the quotient rule. So I'm going to write down 3, and then it's actually 3/4 is the number. And then I'm going to write down t to the negative 3. So see how I wrote that differently? You see the number 3/4, and then just the t to the negative 3. So I was able to write it without a fraction having a variable in there with the fraction. All right, so what's the derivative here using, again, the power rule? Negative 3 times 3 is negative 9. Subtract 1 to the exponent, and it's done. So if we can do a little bit of algebra, it definitely makes it a little bit simpler to do the calculus. Number 4. Again, right away I'm going to write it. Can you write it calculus friendly? Press pause. How can you write that better? So I'm going to write down x squared subtract x to the exponent 1/2. Then when I take the derivative, I'm going to use the chain rule, which is really the power rule, just having a chain connected to it. So 1/2 times 1 in front, subtract 1 to the exponent. Then what's the derivative of the base? That's 2x minus 1, and it's done. Here, number 5, what rule are we going to use to be able to take the derivative? And the answer is we're going to use the product rule. The first times the derivative of the second. Notice there could have been a chain, but the derivative of the base is 1, so we don't need it. Plus the second times the derivative of the first. I don't need it because the derivative of the first is 1, but it's there just so you see the form. But it's not necessary. Number 6. Here's one where I'm just going to leave it the way it is and do the quotient rule. All right, press pause. Do you want to try to review? Do you remember the quotient rule? Try. All right, so the bottom times the derivative of the top, subtract the top. The signs matter. Now, I don't need a 1, but it's there. Just kind of hold the place so you can see the form of the formula. And then the bottom squared. All right, were you able to do that without me doing it first for you? That's the goal, right? Number 7. Here's an example where I'm going to do some algebra. Now, what do I notice is there's a monomial at the bottom, which means I can write this as x cubed over x squared and x squared over x squared. So that's only helpful because that just becomes x minus 1. Well, the derivative of that is 1, and it makes it super simple to get through. So notice the steps I took to first do algebra and then the derivative of x is 1, of negative 1 is 0, and you have the answer. So instead of doing the quotient rule, see how much easier it is to do a little bit of algebra and then do the calculus. Number 8. We have negative 3, 2 subtract 3x squared. All right, this is going to be the chain rule. So notice not the product rule because it's a constant being multiplied in front. If it was an algebra term that had x's or variables in it and so on, then you'd have to do the product rule. But a constant in front, just the chain rule. So 2 times negative 3, subtract 1 to the exponent. I don't need it, but you can put it there. And then what's the derivative of the base? So the derivative of 2 is 0, and of negative 3x is negative 3. Done. All right, number 9. Use the limit definition to find the derivative. Again, what we don't practice, we forget. So if I want to find the derivative using limits, it's the limit as h approaches 0. The numerator, x squared plus 1. So it'll be x plus h squared plus 1 minus x squared plus 1 all over h. So are you able to do a substitution? So you take out x and put in x plus h squared plus 1, subtract, use parentheses, just put in the function over h. Now some algebra. Don't forget the limit notation. Here we are. So for the limit notation here, there it is. Do some algebra. Can you expand this now, please? Without having to FOIL, draw a box, all those things. Just expand it. X squared plus 2xh plus h squared plus 1 minus x squared minus 1. So no parentheses, a little bit of algebra, all over h. Don't leave. Again, the limit notation stays. Next, combine like terms, x squared minus x squared. 1 take away 1. So we're left with 2xh plus h squared over h. Next, factor out, or you can divide out right now. But if I factor out an h, you can now see that the h's divide out, plug in 0, and you're left with 2x. And is that the answer if you just did the power rule? Yes. Perfect. But you didn't forget that a derivative at its foundation is to do a limit. Number 10. In number 10, you're given a function, f at x equals x squared subtract 2x. And you're supposed to find the derivative at 3, there it is, using the alternate limit definition. So what's the alternate one? So this is the one where you say when x is approaching whatever that x coordinate is. So at 3 in this case. Then you write down the function, x squared minus 2x, subtract, and then you're going to plug 3 in. That's 9, take away 6, and that's all over x minus 3. So that's the alternate definition. Again, I'm going to keep the limit notation until the very end. So I can factor the numerator. That is x subtract 3, x plus 1. So two numbers that multiply to negative 3 and combine to negative 2. Notice the x subtract 3's divide out. And now plug in 3 and you get the answer 4. Number 11. Y equals. Now right away I notice I don't like the way it looks. 1 over x squared. Write it better. 1 over 2x. Use parentheses but write it better. And then it asks for the second derivative. So the first derivative I need, and then I can do the second derivative. So the first derivative is negative 2, subtract 1 to the exponent. Then negative times the positive is negative. Subtract 1 to the exponent times the derivative of 2x, the base is 2. So there's a little chain there. So I'm going to just clean this up just a little bit. I'm just going to put the 2 in front. All right, so now I'm going to do the second derivative. So, and I'm not worried about simplifying it. Negative 3 times negative 2 is positive 6. Subtract 1 to the exponent. A negative times a negative is positive 4. Subtract 1 to the exponent. And then the derivative of 2x is 2. There's the hook. Done. Number 12. You're given a function to find the derivative. So what rule or what process are we going to use to take the derivative here? So not the product and quotient, power, all those rules. This one, because the x's and y's are together, it's not explicit, it's implicit. We have to take the derivative implicitly with respect to x in this case. So the derivative of x squared is 2x. Now be careful. xy means product rule. xy beside each other means product rule. That's the first times the derivative of the second. Now the derivative of y is 1, but it needs the hook. And that hook is y prime, or dy by dx, plus the second times the derivative of the first. And that should be a -1 for the negative x. The derivative of y squared is 2y, but it needs the hook y prime. So whenever you're taking the derivative and has a y in it, it needs that extra hook of y prime when we do that. Now some algebra to get y prime by itself. So negative x y prime plus 2y y prime, they're going to stay. I'm going to subtract 2x, and that's negative y, so I'm going to add y to the other side. Then I'm going to factor out a y prime, that's negative x plus 2y. And then the last step is to divide. And now you found the derivative implicitly. And most of the time, your answer is going to have x and y in it. So don't be discouraged by that, and you have your answer. Number 13. Find an equation of the tangent line. So again, what do I do when I see that? Equation of a tangent line. I'm going to write down x equals, y equals, m equals. So what am I given? So first I'm given a point, which is 1 and -2, so that's nice. And then to find the slope, I need the derivative at 1. Now I'm actually going to find the derivative using both, the 1 and the -2. So I'm not going to write that down. So first of all, I need to take the derivative, and I'm probably going to need both coordinates to do it because I need to derive this implicitly. So what's the derivative here? Oops, let me just get right to it. So x squared. So we're given that x squared subtract xy plus y squared equals 5. So I'm going to do this implicitly. So that's 2x. Now notice that x times y is going to be the product rule. All right, I'll be back. Just 1 second. All right, so the phone keeps ringing. It's okay. So the first times the derivative of the second plus the second times the derivative of the first, and then we have 2y and that derivative, and then the derivative of 5 is 0. Oh, I knew this was going to happen. So now we're going to get y prime by itself. So we have negative x y prime, and the other one is 2y y prime. And then on the other side, we're going to subtract 2x, and negative y means we're going to add y to the right side. We're going to factor out a y prime. So you have negative x plus 2y. And then we're going to divide to get the derivative by itself. So we did all that work to be able to find the slope at this point. Now, to find the slope at that point, which is at 1, -2, where there's an x, I'm going to plug in 1. Where there's a y is -2. And then I'm going to be careful and simplify it. So I plug in 1 for x and -2 for y, and then I simplify. So -2 and -2 is -4. -1 and -4 is -5. Simplify it, and you get positive 4 over 5. Make sure that I did that right. Number 13. Oh, you know what? Darn it. I wrote down the one from 12. This is from 12. See what happens, right? Got a call in the background? All right, let's do it right. It's okay. You can do that right now and take a picture of it at the end, and it's okay. Let's do it correctly. So for number 13 was x squared plus 2y plus y squared equals 1. Take the derivative. That's 2x That's 2, but it needs a y prime. That's 2y, but it needs a y prime, and 0. Then, when I get y prime by itself, if it has a y prime, it stays. Positive 2x becomes negative 2x on the other side. Factor the y prime, and then divide. So, the more we practice, right, the better we'll get. Next, we find the derivative at 1 and negative 2. So, to do that, where there's an x and where there's a y, and then simplify it. So that's negative 2. Now 2 take away 4 is negative 2, so that slope is just 1. So come back here. This is just 1. So now take all of this, 1, negative 2, and 1, and write the equation of a line. That's it. So that would be y equals 1, x minus 1, subtract 2. There is your equation of the tangent line. I'm sorry I did the other one. I read the wrong one, so forgive me for that. That's number 13. Number 14. And this will be our last one for this part, and then we'll do a part 2 for the second half of the review. So find an equation of the normal line. Make sure I write it down right. Gee willikers. 2x subtract 1. Now, I'm going to write this as 2/3. So it's squared and the cube root, so I can write it with that fraction. The normal line at the point 1, 1. So x and y is 1. I'm going to find the slope of the tangent line and then do the opposite reciprocal for normal. So tangent and normal are perpendicular. So if I find 1, I just do the opposite reciprocal, and then I have what I need. So in other words, I need to take the derivative. So that's 2/3, 2x subtract 1, negative 1/3, times 2. Next, we're going to plug in. So for this, I just need the x coordinate. So if I plug in the x coordinate, 2 times 1 is 2, take away 1. 1 to any exponent is equal to 1. And then you're left with 2/3 times 2. So I find the slope to be 4/3. Let me double check for 14. And then the question is, the perpendicular slope to that would be negative 3/4, because it's the opposite sign and reciprocal. So using these three numbers, can you write the equation of a line? Y equals negative 3/4. Change the sign for x, keep it for y. Done. All right. I am proud of you for doing your work. Mr. G Math over and out. And until next time, and we'll get part 2 going soon.